Hi. The MusicBox is not a very complicated assignment, but it is a capstone project of this course, and the time that you have available to carry it out is limited. So I thought that it might be useful to offer this additional presentation highlighting some design hints. At the end, I expect that you will be able to explain in your own words the organization of the data path architecture that will be discussed here as an example, and to describe one possible ASMD chart organization. The presentation comprises 4 parts, the first 3 of which relate to the usual design sequence for this type of circuits: the data path architecture, the ASMD chart organization, and the simulation results. We will then close by looking at some expansion possibilities that you might wish to consider. So let's start by the beginning. This slide shows one possible organization for the data path. The need for each block is pretty much straightforward. We need a UART to receive the ASCII codes via RS232C. And you may just pick any already available version of this block, but make sure that you understand what it does and how it works. We need the memory to store the ASCII codes representing the musical notes and the start and end control codes. We need a counter to generate the address for the memory. We also need a modulus M counter to generate the ticking pulses at the appropriate frequencies for each musical note, and the toggle flip-flop to convert the ticking pulses into a square wave. Of course, the ASCII codes representing each musical note cannot be directly used as the counting limit for the modulus M counter, so we need the code converter. And finally, we need the timer to generate the duration required for each musical note. It's easy to understand how these various blocks interact, so there is not much science required to draw the interconnections down. You also know how to control them and what kind of information they may provide, so it shouldn't be difficult to represent the inputs and outputs between the data path and the control path. This will surely not be the only possible way of representing a data path architecture for this application, and you are encouraged to criticize it and to consider variants that you may wish to explore. Whatever the final architecture that you may choose, we are now ready to start looking at the ASMD chart organization. I have chosen to consider 4 main classes of states corresponding to the operating modes indicated in this slide. We will start by an initial state where we wait for the arrival of ASCII codes, and when that happens, we must check if they are valid before storing them into memory. By valid, I mean that they are either a start or end code, or else a musical note belonging to octaves 4 or 5. When all the melody codes have been downloaded and stored into memory, all we have to do is to wait for the play button to be pressed, or otherwise for another sequence of codes to start downloading. Let me show you the simulation results that I obtained for my own implementation. I have decided to include only one set of waveforms as an illustrative example, but it will, of course, come up with a variety of situations documenting the various operating modes covered by your own simulation. What you are seeing here is the sequence following the play command. Notice the upward tick in the play waveform, third from the bottom, and the execution of 2 notes. For the convenience of using consecutive keys in 2 rows of the computer keyboard, the upper row for octave 4 and the lower for octave 5, I have chosen these somewhat strange ASCII codes to represent each musical note. You can see that note P plays at a lower frequency, and then, after its duration, which is obviously much shorter than half a second, note J starts to play for the same duration. Please pause the video and check the waveforms along the timeline shown. What can you do if you want to expand your work? I have chosen to leave you these two recommendations. You might wish to convert your MusicBox into an electronic piano, and for that purpose, all that you need to do is to play each note immediately as it is received. You can choose to keep playing it until another key is pressed. You might also wish to support standard musical notations like the ABC notation, which is another form of text representation of musical notes. Supporting the ABC notation will enable you to play thousands of tunes that you can download from multiple websites. I hope that you will enjoy this assignment. Thanks for your attention.